And today being first session, we'll start slightly slow. So, and as we go along, we'll have to pick up little speed so that we finish. I'm targeting to finish the revision also by end of January. Let's just get started. And today, this is what we are going to do. Kinematics, this session, in afternoon session, graphs and some questions on uniform acceleration, which should be fairly simple. Let's just start with very basics. See, you see two things here. This thing cross indicates this junction, this is a point here. And this object, if you take P is a point-like object. Q is not a point-like object. Okay, so when we define position, position can be defined only for P. It cannot be defined for Q. That is first a small thing we need to understand here. P will have a unique position at an instance, but not Q. But it has multiple points. When we talk about position, which point are we talking about? Okay, and to define position, even for point P, intersection point of this cross here, what is this position? Define the position of any point-like object. We need a frame of reference. We need a reference system, which is coordinate system, and coordinate system becomes the, so we can define position only with respect to a coordinate system. And many times we say the coordinate system is nothing but position of observer, and it should also have a something like a stopwatch attached. We should measure time as well. So position always with respect to a reference system or an observer or a coordinate system. So this is something, if I define something like this, this becomes my frame of reference. So what is frame of reference in? When we talk about kinematics, kinematics is about motion. Motion is we say is a combined property of object and observer. So there must be a frame of reference, then only you can talk about motion. Frame of reference is a coordinate system with a stopwatch. Right. So what is position of point? So one position of point with respect to frame of reference. This is a position vector. Position vector is directed from origin towards the point. This is the direction of arrow, which is pretty similar. What is motion with reference to frame of system? If we change in position vector of point as the time changes, with time, if the position of P changes, frame of this given frame of reference, then we say the point is in motion in this frame of reference. Change in position with time. Okay, so position pair is this arrow. In case of what is one-dimensional motion, if the particle moves, you see at different instances it will have different positions. And at all instances, if positions are such that all position we take the locus of all positions. If locus of all position is a straight line, that kind of motion is called a one-dimensional motion. So one-dimensional motion, in all instances, the point lies on a straight line. That becomes one-dimensional motion. And one-dimensional motion becomes a little easier. What is the advantage of one-dimensional motion? Position vector is a vector quantity. And vector, we need to define the direction. In case of one-dimensional motion, we can define the direction only with plus and minus sign. Plus and minus sign is enough. If we choose a frame of reference which is along that line, the sign is enough to define a vector quantity. That's a key advantage of 1D motion. Sign is enough. Another point I will discuss briefly, and this point is relevant as we go along later on. See what we see here. This is a kind of, this is, see, just imagine this is a box. We see a side view of the box. And I marked some other point also in the box. This box is moved like along this path. So what we are doing, this particular point on the box is moved from here to here. What kind of motion this box has suffered? Two things are important here. One, the shape of box has not changed. The dimension of box has not changed. The dimension remains same. That's called rigid object. What do we define as a rigid object? Any two particles, if we take, the distance between any two particles and the object remains unchanged. It means its dimension has not changed. It's a rigid object. And second thing, if it has moved like this is a rigid object undergoing translation. What is pure translation? Translation means, and translation is important. In case of translation, its orientation does not change. So pure translation means no change in orientation. Rigid body translation. So this is the example of rigid body translation. So any line, if I see whatever orientation this particular line had, here also it had same orientation. Or another way to understand translation, any 2 points if I take on the object P and Q, if this point is P, if I take another point Q, it had particular orientation. During this motion, this orientation of any 2 points on the object does not change. That's a translation. And in case of translation, there's very one important thing here. See, if I look at this object, can we define its displacement? It becomes difficult to define its displacement because I cannot define the position of this object. So I can define position of a particle on the object. This particular point on the object has along this path has moved here. If I had to look displacement, this is the displacement of one particular point on the object. But in case of rigid body translation, every particle in the object undergoes same displacement. Let's say I have marked another point P in the color. So if I look at this point also, any random point if I take, I'll find its displacement will exactly be same of displacement of any other. So since all particles in case of rigid body translation have same displacement, that's why we can treat a rigid body in translation as a point object. That's the reason in laws of motion also we treat as a point object. Rigid body translation, 2 points. Rigid body, interparticle distance does not change. Translation, orientation of any orientation of line connecting any 2 point does not change. Okay. So rigid body translation, all particles undergo identical displacement, and this understanding is relevant in case of laws of motion, and even more so when we come to rotation motion. Okay. Now coming to kinematics. Kinematics is basically okay. So we understand basic things. I don't have to tell. So when we talk about a given time interval, we are talking about 2 instances of time. So 2 instances of time, the stopwatch is on, and 2 instances of time. If initial instance, the particle is here, and I find how it moves. What does displacement mean? So this is something the initial particle has moved from here. So what I find here. What is displacement? Displacement, this is where the particle was at time interval, at the time instance t1. Its position has shifted to another point at time instance t2. What is the time interval? t2 minus t1 is the time interval. And this is the position it has shifted. So what is a displacement? Displacement only depends on initial and final position. So if I have to find displacement between time interval t1 and t2, I only need to know its position. There's no requirement to know the path it has taken. So displacement only depends on initial and final position, is independent of path. And this is a displacement from here. This is a displacement during this time interval. We call this delta r vector. And this vector is also equal to this vector plus this vector. What is this vector? If I go from here to here, this vector, if this is initial position vector, and this is the final position vector. Displacement vector is RF minus RI, bar vectors. The final position minus initial vector vector. It's independent of path. But this is a path the particle has taken. When we talk about distance, what is distance? Distance is actual length of the path it has taken. And when we talk about displacement, to find the distance traveled, or to find the path length, we need to know the position of particle at all instances of time. All instances of time, if I know what the position is, if I connect all those positions, I get the actual path taken by the particle. And we can calculate the actual path length only in certain cases. Actual path length can be taken only when the path is straight, or is it in form of a polygon or a circular path. Any other path, then we cannot calculate the distance traveled. Sorry, the displacement I've written, this is distance. Distance is path length. We correct this one, I have to correct that. Distance is path length. And path length can be only calculated for straight. Polygon also we can do so, and circular path. Any other curve we cannot calculate. And the distance traveled is equal to displacement only for unidirectional motion. What does unidirectional motion means? The direction of motion should not change. Even if the particle is going like this, the moment it becomes like this, here also it has changed its direction. So even it reverses direction, this change of direction, in that case, distance traveled and displacement magnitude are not equal. When we talk about displacement, mostly when we are comparing distance with displacement, we are comparing the magnitude of displacement. So this is equal to delta r only in case of unidirectional motion. Otherwise, distance is always greater. These simple points. What is average velocity? Displacement, average velocity in a given time interval. So what is average velocity between time instance t1 and t2? I should know what the position of point is at time t1, which is ri, and what is position vector at time t2, which is rf or bar vector. They are vector quantities, and this becomes my average velocity. So what is direction of average velocity? Direction of average velocity, this is vector quantity, this is scalar quantity. Direction velocity same as displacement vector. Instantaneous velocity, when this time interval becomes approaches zero, it becomes instantaneous velocity. And instantaneous speed and magnitude of instantaneous velocities are equal. Because when we time interval becomes very small, even if the path is curved, for a very small time interval, the length of the path becomes too small. If the length of path is very small, it is equal to a straight path. So this also is small point, but important point. Instantaneous speed is equal to magnitude of instantaneous velocity. In case of 1D, average speed is greater than magnitude of average velocity whenever the direction changes or reverses. Any change in direction, this quantity, average speed, will always be greater than magnitude of average velocity. So these are simple points. Let's go on to some simpler. And some of the questions very simple. I'll quickly go through. Something like this, something on distance, displacement, velocity, and speed. Okay, we'll very quickly go through. Clock is something you can visualize a clock, which has a second head, 2 centimeter long. So clock, this is second hand, and this is 2 centimeter long. Find the average speed and modulus of average velocity of the second hand at 15 seconds. Moved as a tip, it becomes a point. So we are talking about motion of a particular point in 15 seconds. So this is my initial distance, and after 15 seconds, this is how it will look like. This is my, and this is time interval delta t, time interval delta t. And whenever we write t, we see later on the formula also, but t normally indicates actually time interval. So during this time interval, this is the path the tip of the second head is taken. So this is the path length, and direction is continuously changing. Because earlier, this when it started moving, this was the direction of motion. At this particular time, this is the direction of instantaneous velocity. Since the direction is continuously changing, even before I start, I know the distance traveled and displacements are not equal, and the speed and velocities also will not be equal. Very easily, we can calculate what is the path length. Path length will be equal to 1/4 of the circumference, and displacement will be the hypotenuse of the triangle. This is displacement. And we divide displacement by 15 seconds, I get velocity magnitude. I get not distance traveled by 15 seconds, I get speed. These are the values. We can easily calculate. Okay. That's also a common question. A wheel of a radius 1 meter rolls forward half a revolution on a horizontal ground. The magnitude of displacement of the point on the wheel initially in contact with the ground. So what we have to calculate, first thing what I look at, okay, I need to calculate displacement. Whenever we talk about displacement, there's an initial position, there's a final position. Is initial position and final position clearly defined? I think it's fairly clearly defined. If I convert in terms of a figure, this is a wheel of radius 1 meter. It rolls forward half a revolution. What does half a revolution mean? See, when it completes with this, you see, if I mark this point here, so this is a point. It looks pretty big here, but assume this is just a point here, which is in contact with the surface. What is full revolution means, when this point, as it goes, start rolling, when this point comes in contact with the ground again, it has completed one full revolution. Half revolution means what? Half revolution means this point, if this point had again come in contact, would have been full revolution. Half revolution is the point which is here, which is on the other side, diametrically above this point. When this point comes in contact with the ground, it means it's a half a revolution. Half a revolution is how much distance it will move forward. It will move forward a distance equal to half the circumference. So this is how it will move. And this distance will be equal to pi r. Just like if you just imagine this semicircular path, if you straighten it out, this part, this is suppose it's a ring, you cut the ring into two half, you straighten this path out, lay it on the ground. That's how this path will, this color will come here. And when this point comes to the bottom, what will happen? This point will go to the top. And if we actually imagine this wheel being rolled on the surface, and if I observe position of this particle at all instances from a frame of reference which is at rest, this particle will have a little odd kind of path. It may have something like this. It may move like this. And it's not a, and this path is called a cycloid. Can we calculate this path length? We cannot calculate this path length. As I mentioned here, the actual path which has been taken, the path length can be calculated only when it is straight line, polygon, or a part of an arc of a circle, or is arc of a circle. So we cannot calculate path length, but displacement can be calculated. So what is the displacement? These are two instances. This is my initial position, and this is my final position. So when we talk about displacement, displacement is a vector connecting from initial point to the final point. This is my displacement. And what is the magnitude of displacement? This height is 2r. This length is pi r. Magnitude of displacement is hypotenuse. This also is fairly simple. Okay, and trajectory is called as cycloid. Path length cannot be easily calculated. So mathematically is possible, but not within our purview. Okay, so this can be done. Now coming to this, a very simple distance displacement, average speed. And let's quickly understand what is speed. Speed is distance by time. So when we talk about average speed over a time interval, it is what is the distance traveled during the time interval divided by the time interval. Okay. And let's step when we talk about average, and this kind of thing, we have done it several times in physics, and let's understand once again. So what is given in this case here? Different speed for two time intervals. So for time interval T1, it maintains a speed of V1, and for second time interval T2, the speed is V2. Suddenly from here, the speed changes. From here to here, uniform speed. From here to here, uniform speed. So there are two different speeds. It covers a certain distance. This is the total distance, assume it has traveled. Now, what does average speed mean? Average speed is something similar to what we have done, like equivalent resistance, equivalent capacitance, in case of heat transfer also equivalent conductivity. So when we talk about something, what is it? Can we replace this two speed with one speed which has similar result? So can we replace this V1, V2 with an average velocity which continues for a time interval T1 plus T2 such that the distance traveled is equal? That's the concept behind average velocity. We can replace two velocities with one common velocity, all other parameters remaining same. So different speed. So that's pretty simple. What is the average speed? Constant speed, if maintained for time interval T1 plus T2, will have same distance covered. So if we equate that one, it's very simple. So what is VA equal to? The total distance covered is V1 T1 here, this distance plus distance. So this total distance covered divided by total time interval. That is VA. Okay. And if T1 and T2 both are equal, if V1 and V2 velocities are maintained for equal time interval, in that case, average velocity becomes V1 plus V2 by 2, T1 being equal to T2. So average speed is arithmetical mean, time intervals are equal. Very easily it can be calculated. Second case is common. This is something you see earlier, it was maintained for time interval T1 and T2 were given. Now it is given something like this. You are driving the speed of 20 kilometers per hour for first 10 kilometers and 30 kilometers per hour for next 30 kilometers. So it is something like that. You are maintaining a constant speed for certain distance and different value of constant speed for different distance. So what is given, not time, the distances are given. Again, what is the average velocity? Average velocity also, if I maintain this average velocity for a time interval, so this journey would have taken time T1. This part of the travel has taken time T2. Here the total time taken is T1 plus T2. So if average velocity is such value, the average velocity is maintained for a time interval T1 plus T2, then this also should result in same distance traveled. So that's a concept, different speed for two different distances. So I can replace these two speed for the entire duration, the entire distance with one common speed. And if we just simply substitute what is the average speed, total distance by total time. Total distance is S1 plus S2. Total time is T1 plus T2. But what is T1? T1 is V1 by S1 and V2 by S2. We simply substitute those values, very simple calculations. And here also we notice if S1 is equal to S2, this term becomes equal to, both are equal, S1 and S2. So numerator becomes equal to 2S. And okay, basically it becomes equal to 2V1, V2 divided by V1 plus V2, which is nothing but harmonic mean. So average speed is equal to harmonic mean if distances are equal. Very simple concept. Let's see some more simple application of speed, average speed. A particle moving in a straight line covers half the distance with the speed of 3 meters per second. Other half the distance is covered in equal time intervals with the speed of 4.5 meter and 7.5 meter. This is a common question which is done in everywhere. Let's see how we can solve this question with better understanding and very quickly. What is the average speed of particle during its entire motion? Let's first try and represent in form of a simple figure. What is given here? See, let's see this point A and B. So here, whatever is not given, we assume those values. The total half the distance. Here, the distance has to some value. Let's see that the distance is equal to D. If the distance between 2 points, so it is talking about travel between 2 points A and B. Distance is D. So we maintain a speed value solved in terms of variable. So for half the distance, for a distance equal to D by 2, constant speed of V1. Now what is left is remaining half the journey. The remaining half journey, what it does, or covered in 2 equal time intervals. So if this total time taken is 2t, half that for time t, it maintains speed V2. For other time t, it maintains speed V3. For this journey, there are 3 different speeds. What is the average speed? How do I calculate very quickly? Very quickly, if I have to calculate, first thing what I notice here, as we do in case of equivalent resistance, capacitance and all, first I'll calculate this very easy. Time intervals are equal. I can replace these 2 velocities with one velocity for a distance equal to d. What is the velocity I can replace with? Time intervals are equal. I can replace these 2 velocities with an equal velocity, which is v2 plus v3 divided by 2. For this distance and for this time interval. So moment now it becomes 2 things here. So it becomes velocity v1 here, and this velocity is let's call v2 dash, and the distances are equal. Harmonic mean of this becomes average velocity. So what we do, 2 parts of travel equal time interval with velocity, average velocity, which is arithmetical mean. And so if I have to actually solve these questions here, what are these values here? V2 was equal to 4.5 and V3 was 7.5. If I would take its average velocity, it's 12. I would replace with 6 meters per second. It is equivalent to this half the distance being traveled at a speed of 6 meters per second. And first part of the distance, this is equal to 3. What is the total? What is the average for the entire distance? Either I can directly use harmonic mean, or I can even calculate. This is something that's very simple. So 2 into first velocity into second velocity into 3 plus 6. So pretty simple. So I think this kind of questions are fairly simple ones. And okay. One more question. This is very simple. I think I will just a particle is moving along a circular path of radius r. First quarter of a circle travels with the speed v and covers the third of a circle with speed 2v, and finally the remaining part is speed 3v. It is moving in a circular path. The question is about speed. So when we talk about speed, actually distance alone is important, direction is not important. So rather than treating this question as a circular path, had this path been straight, and it's a full circular path, so can we, if I circular path, if I consider straight path also, it doesn't change anything. In case of speed, direction is not relevant. So conceptually, what I can do, I can cut the circle and take as a straight path also. We can do so even doing a solve in case of circle also, both ways, but I find this much easier. So if I think what is the total distance traveled? Total distance traveled is equal to perimeter p. It travels first quarter distance, means it travels a distance p by 4 with the speed v. Then travels 1/3 of the circle. 1/3 of the circle means 1/3 of the perimeter with speed 2v. The remaining part, p minus sum of these two, this becomes the remaining length. It travels speed 3v. Can we calculate average speed? Very simple. We calculate total distance. We calculate t1, t2, t3, divide by time. So what will average speed in this case? Average speed will total distance, which is 5 meter, divided by T1 plus T2 plus T3. What is T1, T3? T1, T2, T3. So they are fairly simple questions, and I just brushing on this topic. They're pretty simple ones, and we don't expect such questions to come in mains. But there's so many other competitive examinations. There are some simple questions come. And if you have a good understanding, you can solve this question with better clarity and better speed as well. Okay. So that is something the answers, but in most cases, given answers here and the sheet I've sent, I think all the questions have an answer. This is a question which had come in mains, and this is a first interesting question. And this is how it was given, and a man in a car at location Q. So there's a car which is moving at location Q on a straight highway. It is moving at the speed v. I'll just keep marking also. And this is actually how it has appeared in examination. It decides to reach a point P in the field. This is a point P, which is there. So this is a highway here, and this is like this is a dusty area, maybe like a field what you see by the side of the road. And it is at a distance d from the highway. This point P, if I drop a perpendicular, the P is the foot of the perpendicular, Pm is equal to d. That's what is given. What is given here is speed of the car in the field. So when it has to reach point P, part of the distance he will has to drive on the highway, and remaining part, some distance he must travel in the field. What is given here is speed in the highway is v. In field, whenever it's traveling in the field, speed is half of the highway speed. What should be the distance rm? So if m is the foot of the perpendicular, what distance ahead of the perpendicular point he should turn and move onto the field so as to reach the point P in minimum time. So the time taken to reach P is minimum. Okay. In this case, let's see what are things which are relevant here. So we have to calculate what should be the distance rm. Let's see the distance rm is x. Let's see how do we go and solve it. Time t to reach P. What has to happen here? That's a figure given. Time t to reach P. How it has to reach from Q to P? It has to reach via point R. Time t reach P via Q. Sorry, I think reach P from Q via R is a function of distance rm. Let me call this distance as x. Will the time taken to move from Q to R to P, this is the total time, is a function of x. I need to find a value of x so that time becomes minimum. So if moment I spot this one, it should give me a clear idea how to solve. I need to write time taken to reach from Q to P as a function of x. And since the time has to be minimum, dt by dx has to be equal to 0. That's a concept I need to apply. Rest all is fairly simple. Let's see that one. Let QM be A. This total distance is A. Now, can I write what is the total time taken from Q to P via R? The time taken will be Q to R. Let's say time T1, and then R to P. This speed is V, and this speed is V by 2. I can very easily write expression for T1 plus T2. Time T to reach P via Q will be equal to this distance becomes A minus X. The distance by speed, that becomes the first part of the time interval. And the time taken from R to P will be equal to this distance divided by speed. What is this distance? This is D and this is X, the root of D squared plus X squared divided by V by 2. Okay, we assume the speed to be V and V by 2. So whenever whatever quantities are not given, we assume those quantities. So this is value of T. How do we get value of X? Now I have to find a base. It's a function of X. It will become a minimum for value of X. Dt by dx is equal to 0. You can easily differentiate and find the value of X here. So this was a recent question. I think maybe 2 years back, this question had come in minutes. And some of you want to understand, this is exactly same as Snell's law. How does it relate to Snell's law? Some of you can think of. So if the light has to reach from point Q to P, it is traveling in one medium where the speed is V. From a rarer medium, it has to travel to denser medium. What is the path it must follow? If I replace with a similar light kind of a question, the answer would be very similar. The light also travels along a path from a given point to other point. It takes a path which takes minimum time. So this Snell law also is based on a similar principle, which is not related to kinematics, but overall I think this is something you can see the relationship between the two. Another question, just to test your understanding on distance and displacement. This is a room of size, the size 2 by 2 and height is 3 meters. And ant is at one corner of the room on the floor. It wants to reach the opposite corner on the roof. If ant can travel only along vertical walls, for whatever reason, it cannot see if it has to reach opposite corner, it can travel only along the vertical walls. What is the minimum distance it has to travel to reach the diagonally opposite corner? Think of it, the question is extremely simple, doesn't involve any complex calculation, any no formula. Let's see how do we solve it. If you visualize this, minimum distance is something like this. So this is a kind of room. This side is also 2 meters. This side also is 2 meters. Height is 3 meters. Let's see, it is at one corner here. And diagonally opposite corner, it has to reach by walking along the wall. See, we know that the distance is minimum and the path is straight. So what has happened here, the path is something that the room is, it cannot be straight path. But actually this cross, if I unfold these two walls, you understand what I'm saying now? If this is, suppose I cut open this box, suppose this is a kind of box, I cut open the box and unfold this here. What is starting point? This is the starting point here. And ant has to reach from here to here. What is the path it must take? It must take this path. So it is something like this. If you see that one, both are similar cases. What is the minimum distance it has to travel? This is 4 meters and this is 3 meters. It has to travel a minimum distance of 5 meters. So this is something, it is similar question. If I fold it in form of a box, it becomes a little different, a little more challenging. Right, okay. So, so far very basics. Now coming to graph. And graph is an important topic and fairly simple topic in my opinion. What does graph mean? Graph, we plot some quantity of mathematically, y is a function of x. This is something when to plot a graph for each value of x, I need to know the value of y. If each value of x, y is known, it becomes a continuous function, it becomes a continuous graph. So that's how we plot y is equal to fx. Now there are two important properties of graph, and that's what we'll see. One is what is the slope of line joining 2 points on the curve. If I take any 2 points on the curve, and if I join them by a line, what is the slope of line joining 2 points on the curve indicate? Slope of that indicates delta y by delta x, and this will be delta y by delta x. And to understand delta y by delta x, it is average rate of change of quantity y with change in quantity x. So this is something so we can understand delta y by delta x in terms of rate of change. Rate of change in y with respect to x. That's what you should understand, average rate. But if we draw a tangent at any point, suppose I draw a tangent, so I choose a particular point here. So what is the point I've chosen? I'm drawing a tangent at a point which has x coordinate of x naught. And the moment I know x naught, I will know the value of y coordinate also. Only is a function. Each value of x, we know the value of y. So corresponding value of y is y naught. And I draw a tangent here. So tangent is something, it becomes a tangent. What I notice here, tangent has a positive slope here. So what is the slope of this tangent here? The slope of tangent is equal to dy by dx at this particular point. This indicates instantaneous rate of change of y with x. Okay. This happens in case of y and x. But in physics, we have some physical quantity on the y-axis, which depends on some other physical quantity which is there on the x-axis. So here, something like this. Since we are at the topic of kinematics, let's understand what does x indicate. X indicate position of a particle having 1D motion. And this is time. How does position of a particle moving along x-axis change in time? So if the graph is drawn, what are the things we can understand? Okay, so if xt graph is drawn, so if I take 2 points here, T1 and T2, this point is, if I draw T1 here, this will be the corresponding position x1 here. If I take another point T2 here, something similar to what I had done earlier, this is a corresponding position x2. If I connect 2 points on the position time graph, many times they write as displacement. Position and displacements are same under certain condition. position and displacement vectors are same if the initial position is at the origin. Then only position and displacement vectors are same. Otherwise, position vector and displacements are different. So position and displacement are same under two conditions. Initial position is at the origin and initial time is taken as 0. Only they are same. So in this case, if I connect these two lines together, what is the slope of line joining 2 points on xt curve indicate? It will indicate delta y, which is equal to delta y is equal to x2 minus x1, which is displacement, by the slope of line joining 2 points on position type graph indicates delta x by delta t by same definition. Delta x by delta t is nothing but average velocity in case of 1D motion. If slope is positive, average velocity is plus. If slope is negative, average velocity is negative, which makes common sense. If slope is positive, if the particle has moved further away from the origin. So that's what you need to understand xt graph. And similarly, if I draw a tangent at any point on xt graph, what is the slope of tangent indicate? Slope of tangent is dy by dt, y-axis by x-axis. But in this case of the slope of tangent, in case of y, there's a position. In case of x, it is time. That's what you need to do. Once we understand y-x curve, it can be applied to any curve which involves two physical quantities. Slope of line in 2 points, delta of quantity on the y-axis divided by delta of the quantity on the x-axis. Here it becomes, slope becomes delta x by delta t. What is delta x by dt? Is equal to average velocity. And tangent, slope of the tangent. So here if I draw tangent, slope is positive. What does positive slope mean? It is having, at this instance, its velocity is positive, given this sign convention. What if I draw the slope tangent here, the slope is 0. What does this mean? At this instance, the velocity is 0. Instantaneous velocity. The slope gives you, slope of a tangent at a point gives you instantaneous velocity at that particular time. Okay. And similarly, if I have VT graph, in place of xt graph, y-axis becomes v. In that case, slope of tangent at any point will be equal to v by dt. Quantity on the y-axis v. What is dv by dt? Is instantaneous acceleration. So any quantity we should be able to do, as well as average slope, instantaneous slope. Sorry, average slope is slope of line joining 2 points, and slope of tangent drawn at a point. You should understand that part. The second thing which is relevant in case of graph is area under the curve. And you have done enough of maths now to understand area under the curve and the x-axis. You know, again, this curve area can be calculated on y-axis, curve and the y-axis, curve and the x-axis. We are interested in area under curve, y-x curve. Y is a function of y. And so this is something, this gives you what is the area of this curve. This is nothing but y dx. And if I add up all such y dx here, so area under the curve and x-axis, this is the equation we know. I am not going to discuss much more. This gives you area under the curve between these 2 points. If this is x1 and this is x2, if I integrate y dx between x1 and x2, this gives you the area under the curve. Okay, that's what we understand here. And what is applicable in case of mathematics? Similar thing will apply in case of physics. Let's see, if we have a VT graph. In VT graph, if I take the area under VT graph and t-axis, what would that indicate? First of all, if I take a small time interval, what does v into dt indicate? So what we notice here, whenever we multiply these two quantities, v into dt will signify a third physical quantity. V dt here means displacement. So whenever two quantities are there, the product of the two quantity may mean a third physical quantity. Area under the curve will be equivalent to a third physical quantity, which is product of these two. In this particular case, v dt. V dt is in displacement. Hence, area represents the sum of all displacement. So between T1 and T2, so it's like this time this indicates a small elemental displacement. If I integrate between two limits T1 to T2, it will give you displacement between time interval T1 to T2. The sequence is T1 is earlier, T2 is later. Similarly, it was FT curve. Suppose any curve is given, our logic is same. So FT curve, what is area? Sorry, I have written FT. So area under the curve, this will be FDT. What is FDT? What is the quantity FDT is? FDT is impulse. So this quantity area under FT curve, it was FT curve, it would have given impulse, and impulse during a time interval is equal to change in momentum. So this is something we can do. Every time we look at a graph, we should understand what does slope signify. Slope signify dy by dx, and what does area signify? Area signify y into d, y dx, product of those two quantities. And it is valid not for kinematics alone, it is valid for all topics in physics. Once we understand area under graph of two physical quantities, represent a third physical quantity, which is product of the two. Okay, so that's how it ends. Let's proceed further. Now coming to uniformly accelerated motion. Uniformly accelerated motion, the value of acceleration is 3 equations of motions are valid. I'm not going to write here 3 equations. But in terms of graphs, and right now I'm concentrating more on graph. So uniformly accelerated motion, A is constant. Or we say velocity changing at a uniform rate. If we draw AT graph here, how would acceleration varying with time? Since the very definition of uniformly accelerated motion is constant, is not varying. If I draw AT graph, it would be horizontal line. How would be VT graph here? The slope indicates acceleration. Since acceleration is constant, it means slope of VT graph will be constant. Slope of VT graph is constant. What does slope indicate? Slope indicates dv by dt, which is acceleration, instantaneous acceleration. If it is constant, its slope is constant. VT graph is a straight line. Okay, and xt graph on integration becomes parabolic. So let's look at try and understand what does this graph indicate. This graph indicate how is the velocity varying with time. What are things I notice here? Initially at time t is equal to 0, velocity is positive. But slope is negative. What does negative slope imply? Even otherwise also you understand as the time progresses, speed is decreasing, is slowing down. At time t naught, velocity becomes 0. And at time greater than t naught, velocity become negative. So what kind of motion it represents here in the graph also, simply looking at the graph, I understand velocity is continuously slowing down, coming to a momentary rest, again reversing its direction, and rate of change of velocity is constant. It's a uniformly accelerated motion, acceleration being opposite to velocity. Acceleration V is positive, acceleration is negative. V is positive here, and slope is negative. So this is a case here. Okay, and we come across displacement in nth second. So these are the only things we need to know: motions and what is displacement in nth second, displacement in n second minus displacement in n minus 1 second. So this kind of graph is retardation. What we notice here, this is initial velocity and you are in the opposite direction. Whenever acceleration is opposite to direction of velocity, particle, 3 things we can break it down motion into 3 important points. Particle will keep slowing down, come to a momentary rest at time t naught. At what time it will come to a rest? At time t is equal to u by a. And till that time, what will be the displacement? This area will be displacement. Till the time it comes to momentary rest. So its motion is something like this. It has started from u. And what is the displacement? Sorry, this is initial velocity u. So this area is equal to u square by 2a. That's the maximum displacement you will have, and reverses direction. And this is important. It comes many times, slowing down, come to momentary rest. When it comes to momentary rest at particular instance of time, what is the time? U by a. It comes from v is equal to u plus at. So this t is equal to u by a, and displacement is u square by 2a, and reverses direction. So this is how we can represent. If whenever these two are in opposite direction, it doesn't matter which we take as positive. It will come here, keep slowing down. This is the position at time t naught. It will come to a state of rest, and this distance will be equal to u square by 2a. Versus direction, right? Distance travel between time and period. Sometimes this is suppose we have to calculate what is the distance travel, not the displacement. What important point we have to keep in mind when we use equation S here. In this 3 equation, use S term. S term is all u, v, and S term all a vector quantity. My equation gives me displacement. It doesn't give you distance travel. And distance travel between time and t1 and t2. Suppose I take this time is I take a simple case here. Suppose this time is equal to 5 seconds. If I have to calculate what is the distance traveled between 1 second and 4 seconds, Between 1 second and 4 seconds, the distance traveled and displacement will be same because the direction is not changing. Similarly, you have to calculate what is the distance traveled between time t is equal to 6 seconds to t is equal to 1 is equal to 6 seconds and t2 is equal to 8 seconds. It will be equal to displacement because between 6 seconds and here both the cases, the time when the direction is changing is not coming within the time interval. So reversal of or change in direction is happening at t is equal to 5 seconds. If the time interval does not involve time t naught, displacement and distance traveled are equal. But if I have to calculate what is the distance traveled between t is equal to 4 seconds and t is equal to 6 seconds, this time interval is spanning the time when the velocity becomes 0. Distance traveled and displacements are unequal. So direction motion changes. That's what you write in mind. So whenever distance traveled, you have to calculate how do we do in terms of area? That's how we do in terms of area. Whenever time t1 and t2, t1 is on one side of t naught and t2 is other side of t naught. So between this time interval, the direction of motion changes. And that's why notice also this up from t1 to t naught, positive displacement, and from here to here, negative displacement. But as far as distance traveled is concerned, I need to add both the quantities here. How do I write here? So whenever it changes is a1 plus mod of a2. I simply add the sum of magnitude of displacement. That's what we need to do in terms of graph. Let's come to some questions on application of graph. This graph here represents the displacement versus time for a particle moving in a straight line. Okay. And whenever I say displacement, I think position vector is a more appropriate quantity, but even displacement and position vectors are same only under certain condition. So this is what is given. I understand here, this is xt graph, or you can call this yt. Sometimes you can replace a s term also, but it means same thing. It is just moving in one dimension. Okay. So during the interval, so there are time intervals. See this OA, this is one time interval, second time interval, third time interval, fourth time interval. What is the sign of acceleration of the particle? What is the sign? When is sign? When we're talking about sign, it could be positive during the time interval. It could be negative. It could be zero also. What is assumed during the time interval, direction of acceleration is not changing. How do I find sign of acceleration? What is given is xt graph. What I understand from here, slope of xt graph. Let's see how do we understand that question. What is acceleration? It's the rate of change of velocity. And what is velocity? Velocity is slope. So if I look at what is acceleration, rate of change of slope of position time graph. Rate of change of position, rate of change of slope. So what does it mean here? See, if I look at this point here, what is the velocity at O? To find velocity at O, I draw a tangent like this. So here at point O, is the velocity positive or negative? At O velocity, whenever from O to A, anywhere I draw the tangent, slope is positive. I hope all of you can easily understand the slope is positive. And what I understand here, the slope is decreasing. If you are walking from here, you will find there the slope is more, here it has become flatter. When we talk about slope, we are talking about magnitude of slope. It is becoming flatter, it is steep here. So slope is positive and decreasing. So what I understand from here, I talked about slope first. Slope is positive and decreasing. What does it mean? From O to A, slope is positive. It means velocity is positive. But slope is decreasing. It means object is moving positive direction and it is slowing down. What does this mean? Object moving in positive direction. So from this statement, that slope is positive and decreasing. It is equivalent to velocity being positive and decreasing. It means if velocity is positive, how do I represent in terms of figure? If velocity is positive here between O to A, and it is decreasing means acceleration is acting in the opposite direction. So what is acceleration between O to A? Is negative. So A to B, then we come to A to B part. A to B part, how do we define in terms of slope? All part I'm defining in terms of slope. Because slope means, instantaneous slope means velocity. Here slope is 0, it means velocity is 0. Between A to B, particle is at rest. No acceleration, acceleration is 0. First part, negative acceleration. This part, 0 acceleration. From here, initially the slope is 0, slope is increasing. Slope is positive and increasing. What is slope and positive increasing? I replace the word slope with velocity. Velocity is positive and increasing. When does velocity means positive? So I mark the velocity like this and increasing. It means acceleration also in the same direction. From B to C, acceleration is positive. How about C to D? Velocity is positive, but velocity slope is constant, velocity is positive, constant. The velocity is positive but not changing. It means acceleration is 0. So here again, this is positive acceleration, this is 0 acceleration. So this question again, those who are not following, please go through that again and make sure that all parts are understood. Because I made all the points, I've written all the points here so that those who want to refer again go through and see that all are well understood. Okay, that's a very simple application of the same. What is given here? Velocity time graph is given. We need to find the displacement and distance traveled. From where to where? Body in 6 seconds. So from this point to this point, what is displacement and what is distance traveled? What we easily understand here, this is area under the curve indicates displacement. So area under V dt curve is displacement, V into dt. Even if we didn't know also, we don't have to remember, multiply the velocity with time, which is displacement with sign. So this part here, this area A1, it represents the displacement from 0 to 2 seconds. A2 is negative, it represents the displacement from 2 to 4 seconds and 4 to 6 seconds. And this part is negative. So when we have to calculate displacement, sum of the area with sign, this is positive, we have to subtract. So this area is 8, and this is, sorry, this area is -4, and this area is +4. So very easily we can arrive at, when we calculate distance travel, even negative sign also we have to take mod of this. Even negative displacement also is equal to distance travel. So this distance, the displacement will be +8 -4 +4. Distance travel will be 8 +4 +4. Sign is immaterial. We add the magnitudes of displacement. That's the answer. Next question. This is acceleration time graph of a particle moving in a straight line shown in the figure. Velocity of the particle at t is equal to 0 is 2 meters per second. Find the velocity at end of the 4th second. Moment I see a graph, I think of what does its slope indicate, what does area indicate. Slope is dA by dt, which is meaningless, and area is a dt. What is a dt equal to? A dt is what? That's what you need to understand, but we know area is equal to dV by dt. So even if I don't know anything also, very easily you can figure out product of these two quantities which are given in this graph here represents change in velocity. So if I calculate area between two time instances, that will give me the change in velocity during that time interval. That's what, based on the relationship dV is equal to dt. What I understand, area under AT curve gives a not change in velocity during the time interval with sign. All these points are important. How do we write in terms of equation? If I apply the equation between 0 second to 4 second, it will be change, it will be V4 minus V0. How do I write this? Second area of triangle from 0 to 4 will be V4 minus V0 will be area under triangle, and V0 value is given. Whatever value is there, I'll substitute with sign. Here it is. I'll substitute this value. So see this. This is a minor points but important points, and you should understand those points well. Area under curve will change in velocity, not velocity. Okay. Last question. Velocity time graph of particle moving in x-axis is shown. Particle start at t is equal to 0 from the origin. What is the equation of velocity and acceleration? Any graph which is given, if it is straight line, we should practice to write its equation very quickly. And it doesn't matter which the quantities are, because movement is straight line, it is simple. It's a y is equal to mx plus c form. In y, in place of y, we'll substitute v. In place of x, there's x here only, velocity displacement. This velocity displacement x graph. So here in place of x, x only. Let me put the slope here. Slope m is equal to -4 and c is equal to 10. So can I write this equation easily? Yes. Y in place of yv, in place of minus 1 by 4 x plus c. This is the equation between velocity and displacement based on the graph. All y is equal to mx, put the coordinate value. In place of y, substitute the whichever quantity there on the y-axis. In place of x, substitute the physical quantity which is there on the x-axis. M is the slope, positive and negative appropriately. And c is the constant y-intercept. Once you get this equation, I can get the equation of acceleration also. Another way to find acceleration. What is the other way to find acceleration here? Another way I could have found the acceleration here is equal to v into dv by dx. What is given here? What is slope here? The slope of this equation is equal to dv by dx. That's the slope. So m here is nothing but dv by dx. So what is acceleration? V into dv by dx. What is v? This is v is given, and dv dx by is equal to minus 4. So I multiplied this term by minus 4. Sorry, minus, what have I done? Sorry, my mistake. This is minus 1 by 4. Slope is, sorry, this is 10 by 40. The minus 1 by 4. So I multiplied this equation by minus 1 by 4. I get my acceleration equation. So getting equation from a figure which is given, a graph is given, should be simple. And all of you should be very proficient in this. If there's any doubt, please practice and make sure that you're up to it. Okay. So that's what you had, man. I'll stop here. And